Hi, students. Welcome to video 27 on fossil fuels. So we're going to start off talking about coal. Coal, the main thing you should know about that is it is the most plentiful fossil fuel, but it is also the dirtiest of the three main ones that we're going to talk about: coal, oil, and natural gas. So 42% of the world's electricity is generated by burning coal. If you get your energy from Duke Power, they burn coal for most of their energy, and so that's how you're getting your electricity. So 98% of our electricity, or 98% of the coal is used for electricity. It is the most abundant fossil fuel in the United States. We have 28% of the reserves, so we do a lot of coal mining. Again, very, very dirty. We'll talk about the negatives of all these things. And the top three coal burning countries are China, US, and India. These are also the top three countries in terms of their population. So looking at the coal consumption, the US has kind of leveled off a little bit, but you'll notice that China has skyrocketed. This is one of the problems with Chinese air pollution. They have some of the biggest air pollution problems in the world right now because of how much coal they are burning. Looking in the United States and the coal deposits, the main thing you should know from this graph is it is kind of in the Midwest areas where we are doing coal mining because that's where the supply is. We also have methane fields that kind of go with coal beds. So these are the places in the United States that we're getting most of our coal, and these are where the 28% reserves are. So the types of coal, we have peat, lignite, bituminous coal, and anthracite. It goes kind of this way, and you'll see in the diagram. Don't worry about subbituminous. It's just a little bit before you get to bituminous. Peat is really not even considered to be a type of coal. It's basically like the decaying organic matter before it's really been pressurized. But you can burn it. You can get some energy. It's very low energy, though, and it contains a lot of sulfur. So make sure you know which of these things contains the most. Going up the spectrum, we've got lignite. It still has low energy, high sulfur content. Bituminous is where you start to get higher energy and lower sulfur content. And anthracite has the highest amount of energy and the lowest amount of sulfur content. So that would be the best thing to burn if you were going to burn coal. Unfortunately, it's also not the most abundant thing out there. So there was a clean coal campaign in 2008. You may have heard the word clean and coal, but the two words don't really go that well together. The Americans for Balanced Energy Choices, this is a really nice way of saying all the coal companies got together and united and basically started spending a ton of money. They went from about an $8,000 advertising budget to $8 million to $30 million. They also sponsored a CNN Democratic presidential debate. So you had the presidential debate sponsored by coal companies. And because of that, no global warming questions were asked. And if you're not aware, global warming and coal is one of the fossil fuels that produces the most CO2, which causes global warming. So just to reiterate, there is no such thing as clean coal. Right now, we do have technologies that can be cleaner than it used to be, but you are still burning a substance that pollutes the atmosphere and releases greenhouse gases. So coal can be turned into a liquid and a gas form. We call these syn fuels, synthetic natural gas and gasoline. You need to know a couple of different advantages and disadvantages of syn fuels. Again, syn fuels have the same disadvantages environmentally as coal because you have to mine the coal to get and create the syn fuels. It also has a low net energy yield. That means that the amount of energy that it takes to form this, it doesn't give you a lot for that amount of energy. It does have a large potential supply, though, because we have a lot of coal, and we could end up using it for vehicle fuel, which we can't use actual solid rock coal for right now. And it would have, moderate costs in terms of how much it would cost consumers. So we're going to go towards oil now, also known as petroleum. This is what petroleum looks like if you just, mined it right out of the ground and drilled. But this is not what you put in your car, so we have to do things to it to get it to that form. Coal is the liquid containing oil is the liquid containing hydrocarbons. Coal would be the solid. And the process that we separate this into different components is called distillation. So we basically get this petroleum out of the ground, we put it in a large tube, we heat it up, and then we can get the different components like gasoline, aviation fuel from it. So here's how that process works. Fractional distillation is what it's called. We separate the fuel into components by boiling points. So you put the oil in, you heat it up, and the first thing to come out is basically our gasoline that you would put in your car. So that's kind of like that clear liquid. It has a slightly yellow tint to it. It doesn't look anything like the black liquid that we just saw, though. So things that require a little bit higher boiling points: aviation fuel, kerosene, diesel is a pretty high boiling point, and things that are industrial fuel sources. Then you get down here to basically after you have heated and taken off all of this stuff, you're left with like this sort of black tar looking stuff. And that can be used for lubricants. It can also be put in asphalt. That's why asphalt is usually that really dark color. But these all products that we get from oil. So the extraction and processing, how do we actually get it to that point? So oil is found in things called anticlines. If you remember, or if you can remember, it looks like an A.
Kelly Ward, please call star 2000.
Sorry.
Kelly Ward, please call
So the oil sits right here, and natural gas is what is basically fumes from the oil. And the oil sits down here, and we drill down. Once we hit the oil, there's a lot of pressure down there, and you basically are relieving that pressure, and so it's drawn up by gravity. Gravity forces the oil basically by pressure towards that drill, and then it goes up the drill. Then we can transport it to a refinery, and that's when we put it in the tube for fractional distillation. So here's your recovery process that we were just talking about. Primary would be pumping it up by gravity that we just said. However, that's not going to get all of the oil. So secondary is now we can inject water and we can basically force the oil up now, add more pressure. And then tertiary is injecting gases like CO2 that are going to force the rest of the oil up. So who has the oil? Who uses it? OPEC countries have 78% of the reserves. Saudi Arabia is considered an OPEC country, and they by themselves have 25%. So here are a couple of different OPEC countries. You don't have to know all of them, but it might be a good idea to know a few. Canada also has 15% of the oil. They have something called oil sand that we'll talk about in a second. The largest consumers are the United States. So we produce 9%, but we consume about 20%. So we are the number one in that consumption category that you need to know. Then you have Japan and China behind them. So this is what tar sand looks like. Most of it is in Canada, so 70% of the tar sands are that we know about anyway are located in Canada. It's basically a mix of clay, sand, water, and bitumen, one of the higher grades of coal. It does have a very high sulfur content though, so when you burn it, you know, you're burning and putting a lot of sulfur into the atmosphere. So this is what Alberta looks like now and then before. Again, this is in Canada, so it's kind of this pristine, you know, very nice looking landscape. And we basically went in and completely destroyed it so that we could get to the tar sands that were underneath the surface. So petrochemicals are the things that we can make with petroleum. So paint, tires, asphalt, we said, carpet, cosmetics, even some of the clothes that we wear, all plastics. These are all things that are made with byproducts of petroleum. So that's what a petrochemical would be. So how long will our supplies last? Both proven and unproven reserves are expected to last or be depleted about 80% depletion between 2050 and 2100. A proven reserve is just something that we're extracting right this second with current technology. Unproven is maybe in the future we would be able to get at it, even with new technology, or we would discover new reserves. So, you know, 2050 is not that far away. So we are looking for alternatives or new technologies to try to extend the life of this petroleum. So finally, we're going to look at natural gas. So coal was the solid form, oil was the liquid form, and natural gas is the gas form. This diagram shows a couple different places where natural gas can be. So gas can kind of migrate up to the surface and it gets trapped by impermeable rock and it can sit there, and then we can drill a hole down, that's called conventional gas, and get it. Or we could go, if this is oil right here, then it sits on the top of the oil. Again, is trapped by rock. Another way that we can get it is coal bed methane deposits. So coal beds also contain natural gas, and you can drill off of there basically when you're strip mining for coal. And then shale gas, the one that we talk about most with fracking, is drilling straight down, and then horizontal drilling, which is unconventional drilling. This is not the normal way of doing it. And then water is injected down, and it separates the rock down here. So who has it? Russia has 31% of our natural gas. Iran has 15%. And this is very similar to oil. We think we're going to have it for about 60 to 120 years or so, give or take some years there. Natural gas is considered the clean fossil fuel. It doesn't mean it has no emissions, but it has less than all the others, coal and petroleum. However, 50 to 90% of methane of natural gas is methane, which is a much worse greenhouse gas than carbon dioxide is. Your conventional natural gas is your normal drilling straight down. That gives you a very high energy yield, doesn't take much to get down there, and you get a lot of stuff from it. So liquefied natural gas is what we use in transportation. It is less dense than air. So that means if it escapes, it goes off into the atmosphere, but it does have a relatively low energy yield. Liquefied petroleum gas is something like propane, butane, and those are more dense than air. So liquefied natural gas is just sort of like methane. And then your liquefied petroleum gas is heavier elements. So if that gets out to the surface, it sits on the surface because it's more dense than the air, which can cause explosions, also human health impacts if you breathe this in. So unconventional drilling is basically where we have to drill horizontally now. And these are things like coal bed methane gas. We have to drill like that. Methane hydrides, if we're talking about shale gas. Traditional fracking is unconventional natural gas drilling. All of these things have a very high environmental impact. The methane hydrates, again, you're burning methane, which is worse than CO2 in the atmosphere. Methane is basically inside ice crystals, and you can burn the ice crystals. It's also found in permafrost in Siberia and the ocean floor, and so you can burn that as well to get you energy. So when we talk about the fracking issue, again, fracking is drilling vertically and then horizontally, and then basically shooting water down the pipe in order to crack open the gas or the rock that's down there and release the gas. So there's two sides to it: the environmentalist side and the industrial or economic side. It does give us jobs, it makes us money, and it makes us less sufficient on other. Or it makes us more self-sufficient. We don't have to rely on other countries as much for oil. But it does destroy the environment. It causes air and water pollution problems, loss of habitat and biodiversity, and it does increase our dependence on fossil fuels. And here's some shale gas in North Carolina. Where are we drilling? It recently became legal in North Carolina to drill or frack in North Carolina. So we are seeing, kind of this big debate about it, and we're going to be seeing what kind of environmental impacts it's having. But you can see, even in, a lot of different counties around where we live, there are places where the fracking industry could potentially make money. All right, that's it. Bring your questions and be ready for a quiz.